everyone. We're going to talk about some of the interferences that often occur in atomic spectroscopy. We'll focus mainly on chemical and spectral interferences. These scattering interferences are usually a bigger problem for the furnace AA, so we'll skip those. Let's distinguish chemical and spectral interferences. And maybe we can talk about chemical interferences on this side and spectral interferences on this side. And I guess if I had to define a chemical interference, I would say that that's when an unexpected chemical, maybe, some sort of a substance, an unexpected chemical forms from the analyte and decreases the analyte signal. And I guess I can think of one example where a chemical interference can lead to a false positive, but let me give you an example. You may remember a few videos ago we talked about how if we have this iron sulfate complex in an aqueous sample, we might be able to nebulize it, but if we're just using an air acetylene flame, we cannot atomize it, so there's no reaction. This would be that unexpected chemical that formed from the analyte and something in the matrix that decreased our analyte signal. This is a chemical interference that we call a non-volatile salt. Right? Not volatile, can't be atomized. Another example that we haven't talked about yet, which we will, is an ionization interference. And one more that we'll talk about is oxide formation. This is the one that can lead to a false positive. So we'll talk about that a little bit later. So that is a chemical interference. Now, if I had to define a spectral interference, I guess I would say that that's when another species, probably another element, absorbs or emits radiation at the same wavelength as the analyte. So let me give you an example. Vanadium, when you're running the ICP, emits radiation at 308.211 nanometers, and aluminum emits radiation very close at 308.215 nanometers. If you're trying to quantify vanadium in the presence of aluminum, aluminum may interfere. It may behave as a spectral interference. Spectral interferences tend to be a larger problem in ICP because you're measuring the emission of radiation, and there could be a lot of different substances emitting radiation. And in general, chemical interferences are a bigger problem in flame and furnace AA, but I'm just going to write down flame AA because that seems to be our focus. Remember, if this forms in an aqueous sample and you're using an ICP, you don't need to worry about no reaction occurring. Remember, the ICP is going to be hot enough to break this down and create gaseous iron atoms. So that's it for now. In our next video, we'll talk about these chemical interferences that you observe in flame AA in more detail. So thanks for listening.